Thank you all for giving up a wonderful sunny day to come and listen to me talk. I hope you don't live to regret it. We shall see. Let me just make sure I set this to the right time. Okay, what I will try and do is not simply talk about my own work, although I will mention that. I will try and give you a sense of what is happening both here and abroad with the goal of improving the lives of older people, which is why I get up in the morning and go to work. Some people might call that altruistic. I don't. I regard it as the best form of life insurance I can possibly buy. So, without further ado, you can nod approbation while you sleep through the rest of my talk, because this is the take-home message. Old age has historically, and by historically I mean throughout human history, been accompanied by poor health. It doesn't have to be like this. It really doesn't. Science is showing us that we should be able to separate these two out. We should be able to improve outcomes for older people. Core to improving outcomes for older people is understanding how the biology of aging worked. For most of human history, that was a black box. And understanding it will change things for the better. But that can only happen if you help us. And I'll show you how you can help us later on. To try and sort of put things in context, I thought I would try and explain a little bit about how the world has changed. If you looked at the world of 1900, average life expectancy, which is how long a baby born in 1900 could expect to live, is only about 30. And it's been 30, 20, 25 through most of human history. And through the 20th century, with improvements to sanitation, postnatal care, prenatal care, antibiotics, life expectancy has gone up very, very markedly. Today it's around about 70 globally. It's much higher in the UK. And the UN thinks that it will reach the age of 82 across the globe by the year 2100. And I think that this is absolutely marvellous, because we talk about the ageing of the population as though it's a problem. I don't know why you can sit there so smug, since you pick up a newspaper and you are the source of all the world's problems by living so long. And I see it rather differently, because every older person is a baby that didn't die. That fact somehow got lost. And unless you are a fan of dead babies, you should be a fan of older people. I don't really see it as a difficult dynamic. And one of the other things that is forgotten is that older people are very, very diverse. This is taken from a marketing analysis done by a company called Wise Branding that set out to segment the older population, the population over the age of 60. This hadn't really been done before. And you can break older people down into a variety of groups. I've just taken a couple of the extremes. On the one hand, you have a group that were called the satisfied innovators. They're typically middle class, they're in really good health, they go to the gym a lot, they play tennis, they're interested in keeping up to date. And on the other side, the other end of the coin, you have this. They were called the bored and depressed. They're often former manual workers, heavily dependent on the state pension, they're in poor health, they often take multiple medicines because they're in poor health. They're socially very isolated. They can't get out because they're not healthy. They watch lots of television. Anybody who has spent any time with daytime television should understand why that is just not good for you. Okay, so there's a huge divergence between these two groups. And really this is the situation that's often forgotten. I look at some of the older people I encounter and I think they're so happy, healthy and rich that they could give me a hand up, actually. But they're not the people I worry about. They're the people I'm mildly jealous of, but I certainly don't worry about them. Many, many other people are not. The poor, the sick, the lonely and the isolated. And these are the people that gerontologists seek to help. And the thing that chiefly separates these two groups is their health status. Even the very wealthy are often isolated. If they are sick, they can't get out, they can't see their friends, those sorts of things. And poor health costs money and causes misery. And this is the problem that society faces and that gerontologists face. If we don't begin to attack the burden of ill health in later life in a meaningful way, we will spend as a society more money than ever before to keep more people than ever before, more miserable than ever before. I have trouble seeing that as a win. What will we do if we succeed? Look on, because I will show you. To try and give you some further context, if we look at health costs today, it's estimated that the overwhelming majority of items dispensed by the NHS go on older people. Most admissions to NHS hospitals occur for older people. And if you read the press, you almost think older people have a gratuitous joy in going to hospital. Now, the only people I know who like going to hospital in the morning are doctors because they get to see their friends. Newsflash, older people don't want to have to queue up at the chemist all day for 5 items, and they don't want to spend 6 hours in A&E or endless waiting for a hospital bed. I have older parents, and they've discovered as they have got older that being sick is a full-time job, and they're quite glad they're not trying to hold another job down by working. So there we go. Okay. It's now going its own way. And so, as I say, the number of older people is growing, and that's a good thing. It's a great success story. The number of people who are ill, unfortunately, is growing at the same rate because being old and being sick are closely correlated. And that tendency is set to increase. This is figures from the UK on healthcare and spending per capita. As you can see, it's expected to increase by percentile amounts that are significantly large, over 400% by the middle of this century. This is the situation unless we do something. And this is what I really wanted to tell you. It doesn't have to be this way. We have known for the whole of human history that age increases vulnerability to disease and vulnerability to functional impairment. By the time you're 85, an average older person will have about 6 distinct clinical conditions. Some people will have as few as 1, some people will have as many as 15. But it's remarkably unusual to be disease-free by that point of the lifespan. And this is because you are the proud owner of a body that has been around for a long time, and you are a member of a species which shows aging. And we now know enough about the physiology of that process to extend the healthy period of life quite routinely in the lab. And there is a fevered debate in the field right now about how best to achieve this in the general population. And this is an incredible journey, certainly for me. When I started as a gerontologist in the late 1980s, we could talk to you with tremendous fervour about why aging existed, about the evolutionary biology of aging. And talking was by far our greatest skill. If you'd asked us how it worked, we could have said we had theories, we had some ideas about how these things worked, but realistically we didn't know. That's changed, and we're now at the point in the field where we can see people seriously proposing methodologies for trials that might extend the healthy period of life. We can also see the pharmaceutical industry beginning to use some of our knowledge to produce interventions that could improve the health of the older population. That's really only happened in my working lifespan, which is not terribly long. I can say that to you because whenever I speak to young people, they look at me and they think I'm geriatric. So it's nice to be here and to be the angry young man of U3A at 50. All right. So, the mid-1980s was really the point at which the dam broke in understanding how the aging process occurred. Firstly, through the pioneering work of a gentleman called Michael Klatz, and then through a series of studies by other scientists, many of them very famous now. Cynthia Kenyon is a name that comes to mind. Single gene mutations were isolated in a variety of the laboratory species which we use, and the three laboratory species we normally use are a little tiny worm called Canorhabditis, Drosophila, which are little flies that will land in your beer if you have a pint this evening, mice. You know, those are the basic ones, and some of us who are a little weird occasionally manage to get humans to volunteer to help them, which is the category I fall into. What makes the first three important to a gerontologist is that they are small and breed very rapidly. What makes the last one important is it's the only species that will pay you to conduct research. So, first of all in C. elegans, then subsequently in these other animals, single gene mutations were identified which greatly extended these animals' lives. They lived much longer because the animals were much healthier. And people start to get very confused about this, but it's really quite simple. Sick things tend to die. Healthy things tend to live a long time. You know, the great thing about working in aging is that you get to dispense bits of Cracker Barrel philosophy in a profound sort of tone of voice. But it is often forgotten in the discourse. Because people said, you know, how are these animals living so long? And the answer came back, because there's nothing wrong with them, that's why. And interestingly, the mutations that cause these animals to live long can also be found in humans, the same sort of pathways. This is a very interesting paper I enjoyed a lot. It shows that one of these genes, one particular form of one of these genes, FOXO3A, if you are fortunate enough to carry the FOXO3A good allele, for want of a better word, an allele is just a form of a gene, then you are physiologically significantly younger than your peer group. You walk a little bit faster, your performance on a range of biochemical tests is very good, and you have much higher grip strength. Physicians love grip strength as a quick measure of how healthy you are. So if we ever end up in an era of frank healthcare rationing, my advice to you is to grab the doctor's hand and crush the bones. Okay? You will look like a good target that will stay alive. There we go. A little bit of free healthcare advice. And as a result of these findings, that single gene mutations will extend lifespan, the focus of research began to shift and should shift further, because most of the scientific community, most of the time, most of society at large, carries around a slightly odd model of the relationship between illness and disease. And it dates back to Galen, to Marcus Aurelius' court physician, who turned round when he was asked what aging was and pretty much said something like this: I can't tell you what aging is, said Galen, but I can tell you what disease is. Disease is disordered or abnormal function, but aging is universal. That which is universal cannot be abnormal, and therefore aging is not a disease. Now, in fairness, he did have a plague outbreak to deal with, so that, you know. And that argument is incredibly powerful, incredibly prevalent. People produce it spontaneously, but it doesn't touch the biology at any point. So don't think about it in those terms. Think about it in these. We have a very few, we've called them aging mechanisms, but what they really are health maintenance mechanisms. And aging occurs because the mechanisms which keep us in good health start to fail. And when they start to fail, those mechanisms of aging produce the things we have chosen to label, and it's a labeling issue really, things we've chosen to label as the diseases of aging, like cardiovascular disease or osteoporosis. The things that we have chosen to label grey hair, you know, natural changes, grey hair, wrinkles. If I asked you what the canonical features of an older gentleman were, you probably wouldn't say significantly increased intimal thickening. You would probably say, they have white hair, they have wrinkles, these sorts of things. We think of these as natural changes because they happen to everybody. And the things we find really difficult to pigeonhole. Hearing loss, joint stiffness, are these diseases? The menopause. Have you caught the menopause? Seems an unusual, But we medicate, or we did medicate for the menopause, when it looked as if the benefits of medication outweighed the risks. And these are all, we think, caused by the failure of a very few health maintenance mechanisms, and the results are illness, periods of morbidity, and eventually death. What are these health maintenance mechanisms? Well, this is a slide from the US where they're currently trying to bridge the gap between researchers who are working on age-related diseases and researchers who self-label as working on aging with something called the Geroscience Initiative, which I think is incredibly timely. And this set of mechanisms were identified as the major causes of a failure to stay in good health. Why did they pick these particular mechanisms? Basically because of what the science started to tell us. One of the most important breakthroughs in, I think, the history of aging research after the identification of long-lived mutants was this little study in 2009. Because the mutants allowed us to identify which genetic pathways were involved in keeping you healthy. And it turns out that one of these is interacted with by an antibiotic. It's just the general name for the class of compound called rapamycin. For those of you who love to collect trivia, rapamycin was isolated from a fungus on Easter Island, which is known as Rapa Nui, so the pharmaceutical company called it rapamycin. If you take mice and you give them low doses of rapamycin, what you see is this. Their survival goes up dramatically, both in males and females. It works in middle life. So why are these animals living so much longer? They're living much longer because they are much healthier. Rapamycin is interfering with the same pathways, by and large, that the long-lived mutants live in. And rapamycin is a drug. Why do gerontologists get excited about a drug? Because the human race has only got about 1,500 of them. That's it. I only found this out actually a few months ago. We only use, I think, about 1,200 of them. The flashy word for a drug is a novel or new molecular entity. And this was brought home to me most strongly the other day when my partner had sinusitis, and we had Lemsip in the house, which contained, I think, paracetamol and caffeine. So I ran out like an idiot and bought her Sinutab, which I discovered contained caffeine and paracetamol. So there are many, many different formulations of these molecules, but there aren't that many of them. And the development of a drug costs sums of money too large to have meaning. More, I think, for many drugs than we spend on many areas of science nationally, full stop. So drugs are expensive, and the idea that you might have one here that could do something useful would be incredibly good. There's some evidence in animal models that it's useful for the treatment of Huntington's. There's a lot of evidence that it's potentially useful for the treatment of Alzheimer's disease. There's plenty of evidence from the mice that these animals are aging more slowly. And one of the major drug companies is currently conducting tests to see if a related drug improves immune function in the elderly. And if that is the case, that would mean that the potential exists to interdict those pathways when you're vaccinating, potentially allowing older people who don't currently make a good response to flu to make one. And the public health potential of that, I think, is really tremendous. It's not quite ready for prime time, but it's good. One interesting thing I found out is that everybody who took who participated in the trial all said they felt absolutely great while they took rapamycin. Now, I have no idea if this is placebo effect or not, but at least 220 old people felt fine as a result of something a drug company did. So there we go, another notable first. Just in case, that was snide, I take that back. Okay. Just in case you thought that this was going to be a purely science-like talk, I couldn't stand up here as a scientist without giving you a large and incomprehensible diagram to demonstrate that I am, by my very nature, more learned and better educated than you are. Okay. There'll be a small test later. If you're interested, this is the pathway that most of the mutants fit into, and mTOR is the major target for this drug, rapamycin. TOR actually stands for target of rapamycin. There we go. Yeah, there isn't a lot to do when you come to name these things, to be brutally honest. Okay, so that's the pathway. How does rapamycin work? Well, I could give you 6 slides, or I can give you an example, and this is just my analogy. Rapamycin works like every overworked mother with a child who adores Lego. Okay, so if you imagine your cells making protein as kids who adore Lego, all right? If you've ever had children who like Lego, you'll know that children will always want brand new boxes of new Lego to assemble into whatever it is that's the particular zeitgeist. If you are a cruel parent, or as some people might say, a reasonably fair one, and turn the supply of pocket money for Lego off because you're sick of treading on it or having it go up the Hoover or find its way into places that no mortal piece of Lego should find themselves, then your child is forced to disassemble the Lego if it wants to make anything new. Thus with cells. Normally, cells are in an environment relatively saturated for nutrients, and TOR sits at the center of the network of proteins within cells that senses if nutrients are available. It's the central nutrient sensor. And so if you have plenty of nutrients, it's always energetically favourable for you to make new protein. You don't bother with the stuff you've already made. You leave it hanging around. If you don't have any nutrients, or if you add rapamycin, which kids the network into thinking there are no nutrients, the cell responds the way a kid will with Lego. It will start to break the old protein, damaged protein down, and reuse it. It has to, because it doesn't have any choices. And this also links very closely to an old observation in the biology of aging, which is that if you take an animal and feed it with a diet that is complete in all regards, but rather deficient in calories, phenomenon called calorie restriction, you will see a significant increase in the animal's lifespan. A slight disclaimer, don't try this at home. No, really, because the levels of restriction that you need can be really quite severe, which I think it's of the order from memory of about 1,500, 1,600 calories for your average fat professor. And that's really a very difficult regime to adhere to. And I sometimes look at it and think, do I want to spend the rest of my life on 1,500 calories a day and never have a curry? Or shall I trade off some weeks against a chicken vindaloo? It doesn't take a lot to work out which option I've gone for, to be brutally honest, but there we go. Okay, so on the one hand, we have compounds like rapamycin, which have the potential to improve health in the general population and have been shown to improve health in a range of model organisms. It's not the only game in town. This is a summary of some work from the University of Birmingham, actually. If you look at a population of previously healthy older people and they have an unfortunate mishap, they've fallen over the cat, they've fallen over a ruck in the carpet. I actually had an almost identical fall last year because I managed to fall in the classic way that an older person falls. I was in an unfamiliar house. uneven floors. It was an old farmhouse. I moved out of the living room, which had the lights on, into the hall that had the lights off. I missed the step. I went whack. And the first thought that occurred to me was not, gosh, I've recapitulated the etiology of an older person's fall. It was, Jesus, I think my back's broken. Now, it wasn't, but I was lucky. Now, if I'd been unfortunate enough to land on my hip, I'd probably have broken it. I'd probably have gone to hospital. And I'd probably have been okay, apart from a limp. If I'd been 15 years older than I am, there's a much higher chance that I would have picked up an exceptionally nasty bacterial infection that had a good chance of killing me. And if that hadn't happened, I would have spent some quality time in the intensive care ward. Okay? Rather not do that. It looks as if what happens is this. Your immune function is controlled, at least in part, by the interaction of two hormones. They're called cortisol and DHEAS. If you're young and you snap a bone, cortisol goes shooting up. DHEAS goes shooting up as well. The system stays in balance and you're fine. We lose the ability to make DHEAS as we get older. And the result is that when you snap a bone, your cortisol level goes up, DHEAS can't move up to compensate, you immunosuppress yourself and you die. Okay? Or if you're lucky, you make it through. Now, this pathway can be interfered with potentially nutritionally, and that's a very active area of research at the moment. There's also, unfortunately, diseases where you have single gene mutations that speed aging up. This is a very famous one that I happen to work on. It's called Werner's syndrome. For the avoidance of doubt, the gentleman with Werner's syndrome is the gentleman on the right of the photograph. The one on the left just has a weight problem, and one of those 1980s ties that was really, really trendy has now gone out. We're both actually 30 in that photo, for comparison. And what we've shown together with our collaborators is that Werner's syndrome is caused by the accumulation in selected tissue lineages of things we call senescent cells. We are able to interdict this process with a class of drugs called the p38 MAP kinase inhibitors, and I'm currently hoping that what we'll be able to do is use these in clinical trials to improve some of the worst features of the disease. We're just at the very start of doing that, but that would be a tremendous benefit if we could do it. And I've been talking to clinicians in Japan, where most of these patients are, about the possibility for that to take place. And the Werner's syndrome work is a very good way to introduce the other major string to our bow, which is this business of senescent cells. Senescent cells are cells that will no longer divide. They stop dividing as an anti-cancer mechanism, and when they stop dividing, they do bad stuff. And they do bad stuff because they want your immune system to come along and kill them, so they're no longer a nuisance. Unfortunately, as you get older, your immune system is itself aging. The result is it doesn't remove senescent cells so well, and the result is that these things build up. And the bad stuff that they do starts to really interfere with your physiology. We've thought this for years. We now have very good evidence that it's actually true. This comes from a classic study done a couple of years ago at the Mayo Clinic using transgenic animals. These are animals made from a single cell, and these animals have been made such that senescent cells can be removed from the animal if you put a drug in the drinking water. Now, these two animals may look like they're different ages to you. The one on the bottom with its nasty little kyphotic back and greying hair. The other one looks a bit plumper and healthier. They're actually the same age. They're litter mates. The one on top has had its senescent cells removed, the drug. The one at the bottom hasn't. It's had nothing done to it. And it isn't just in appearance or a range of physiological parameters where these animals look different. They do things rather differently as well. Notably, things like voluntary wheel running. Some people giggle when I say, oh, you see a vast improvement in voluntary wheel running in these mice. But actually, I put it to you, when was the last time you went for a bloody good run when you felt like death warmed up? Okay? These animals with senescent cells removed are running harder and further because they want to. No one's making the animals do this. And if we scale that up to humans, this is the difference between spending your declining years living independently in your own home or being in a nursing home. So if you look, an older person with their senescent cells removed, I've just scaled this up, can run about twice as far as a standard sort of older person, and rather faster. So this is the difference between having to shuffle along to get the paper and jogging along saying to younger people, will you speed up, please? Some of us have places to go. Okay, so that's what scientists are doing in a nutshell. Some of it's my science, much more of it isn't, and I wish it was, frankly. But what can you do right now? And these are the things that I normally get asked about in the press, lifestyle interventions. I've picked the three. One is beauty products, the other one is exercise, the third is diet. As for beauty products, all I will say is the results speak for themselves. That's me at a function a couple of years ago with a friend who happens to be a model. And I turned around to her and said, can you show me how to pose for the camera effectively? And she said, certainly. This is how you do it. You just look into the lens and remember that the camera loves you. And I feel rather like many people trapped in abusive relationships where I feel I have to keep telling myself that it loves me. Okay? So no, I don't use beauty products. There we go. Exercise is a bit of a two-edged sword, really. There is very little doubt that exercise is beneficial. And for reasons more than the physical. You know, if you own a dog and you take it for a walk, you tend to be rather fitter than somebody who doesn't. You tend to have better outcomes. But there is also a significant social dimension to exercise. As you can see, this is where the kind of slide you normally get shown when people talk about exercise. It's got lots of clean-limbed young people looking fit. This is actually a group of students at the Sports Science Department of Liverpool John Moores, where we held our annual scientific meeting a couple of years ago. You can tell it's a sports science department because someone is wearing shorts. That they always are. And this is a fairly, I think, more typical scene. This is just to show I practice what I preach. The enormous slab of lard there is me, and the four ladies span an age range from near retirement to early 30s. Okay? And it also illustrates something else about exercise, which is it's a social activity as much as anything else. We've been on holiday together, some of us very close indeed. The lady who is the fitness instructor, it's her wedding anniversary today, I think, and she's actually up Mount Ventoux with her husband. You know, I think I'd probably have preferred to spend mine having dinner at a restaurant, but each to their own. And interestingly, exercise is great so long as you are able to do it. And actually what's hidden in that photo is a surprising number of injuries, including ACL reconstruction, slightly dubious hips, those kinds of things. And quite often, I get a little vocal about this, quite often I see in the press there's a kind of subtenor that if only older people would get off their arses and go for a walk, all the health problems of the world would be solved. To which my answer is, fine, when you've got arthritis and fancy doing a marathon, I'll come along and chat. Okay? Exercise is great if you can do it. Diet's very interesting as well. Diet is very, very interesting. And really everything about diet and supplementation, in a sense, can be said with this slide. And it's actually a marvellous study from Lawrence Whalley and Ian Deary at Edinburgh. And it looks at cognition and supplementation, in this case, taking fish oil tablets. What they say is this, that subjects of higher current or original mental ability may be better informed about healthy dietary habits, and because higher cognitive performance is associated with more years of education and higher occupational status, this can ensure a higher income. What do they mean by this? One of the big problems with working out if dietary interventions work in people goes like this. Bright people tend to be health aware. So if they read in the newspapers or something like this that shark cartilage is good for you, because they're health aware, they'll dive in on it, or they'll start taking up yoga or something. And if you aren't sensitive to this effect, you'll find all the bright people are doing this. And you'll infer causation where there is only correlation. And actually, in this particular study, when you subtract age 11 IQ, which the researchers were able to do, the link between fish oil consumption and cognitive ability is still present, but it's much weaker. Okay? So there is that. And there is no doubt that the quality of what you eat is just as important as the amount you eat. These are two interesting papers from a friend of mine called Barbara Shuckett-Hale, who I hope will forgive me because I just came back from her talk. And she waxed lyrical about the benefits of fruits and berries and said, it seems to me that how a fruit or berry is shaped is, some clue to what it will benefit. Walnuts seem to be good for the brain. And went on, and I turned around and said, I think I should be eating more bananas, Barbara. Because I have bow legs. And so there is no doubt that blueberry supplementation does seem to do something. So does drinking, for example, coffee, but not caffeine, because foods are very molecularly complex. There's 300 different compounds in a glass of wine. But look at the amount in this study. These are ways you clue in on what molecules might be beneficial. You do see an improvement in cognition in rats that are supplemented with coffee to the equivalent of about 2 litres of coffee a day. I think if I was drinking that, the only task I would be trying to solve would be toilet mapping, frankly. Okay? And also, blueberry supplementation does improve memory, if you can afford it. The supplementation is about 2 cups of blueberries a day. That's about £900 a year just on fruit, if you shop at Tesco's, which I do. I mean, you may be able to get it cheaper elsewhere. And the people we're trying to help are saying things like this. I worry that I'm buying what I can afford rather than what I really ought to have to keep me healthy. My little treat is having a haircut every 6 weeks. It's not a realistic intervention for some sections of the population unless the social environment changes. And so what then can the satisfied innovators do to help the poorer, the bored, the depressed? And I would suggest help the scientists help them. And I want to make this very clear. This is not me holding out a bucket and begging for your money. I want something much more valuable, actually. I would like your help and your skills and your interest. Because some people will go to a U3A meeting and see a lot of old people and a pompous little man. I don't. I see hundreds of skilled people with some time to devote to improving health outcomes for the older population. Okay? Unfortunately, there is no charitable organisation now exclusively funding research into the biology of ageing. We've started to do it as the British Society for Research on Ageing, but we're just a bunch of scientists. And ageing is a global issue. And so we're starting to have conversations with U3A, with organisations in the United States. I'm actually out there next week. And we're moving into a period in which interventions could start to get delivered to the general public, to people like you. You are both the recipients of any benefits and the reservoir of the skills that we need. I don't get out of a lab very much. Okay? I've never worked in the NHS, and I only encountered the financial term de-risking last week. So there we go. Just to give you a sense of what we're up against, this is the spend on diseases for research versus the spend for the biology of ageing. We're not really swimming in money here. If you go to the US, they spend about $300 a year per head on cancer, about $8 on ageing. It's, again, not as though the centre is ageing research. And unfortunately, in terms of translating these things into benefits, you get what you pay for. You may remember this gentleman, Vince Cable. He was part of a popular comedy double act. And he said there was a strong case for identifying broad problems, for example, the challenges thrown up by an ageing population. That, if you have very good eyesight, is how much he spent. I'm glad that we got a strong case, because God alone knows what we would have got with a weak one. Okay. What happens if we succeed? You know, aging is one of those odd things where people worry if we don't do anything about it, and they worry if we do. Okay, one MP staffer once turned around and said to me, my Member of Parliament is worried about the 200-year-old pensioner. Well, he needn't be. All right? These are the potential beneficial scenarios if our research translates properly. We keep lifespan the same, and we shorten the period you spend sick. We call this compressed morbidity. There is an alternative, but equally beneficial scenario, where we keep the period of sickness roughly the same, but extend the period of good health. What we won't have, we think, is what's sometimes called the nightmare scenario, which is the one everybody automatically jumps to, that you'll double lifespan and spend 70 years with arthritis. All of the data says that this isn't going to happen. It's going to be one of these two. What impact will those scenarios have? This is about the only economic modelling that's ever been done. It's very new, and it's very, very useful. It basically shows that improving the health of older people in general has a larger effect than delaying either cancer or heart disease, and is way better than the baseline. The number of disabled people doesn't increase. In fact, it drops rather markedly. And the United States healthcare system saves money. It saves $7 trillion gross or $4 trillion net once you've paid the entitlements that older people are due. Far better than any of the other leading scenarios. How much is $4 trillion? Well, I had to go looking. It's roughly equivalent to 40% of all the gold that's ever been mined in value. It's enough to buy everybody in the world clean drinking water for about the next 30 years, and it's nearly 2% of total global wealth. And that is money that the US will have to spend unless it does something to deal with the problem. So if we can advance the things that we need to do to improve the health of older people, we save money that we can spend on other things. So I sometimes say that a better world for older people is a better world for everybody. And it's more than a simple throwaway line. So, just to round up, the only thing we have to fear about improving the health of older people is fear that we can't do it or fear that it shouldn't be done. And I will deal with the last little bits of things because I normally get the "are people going to be immortal?" to which the answer is no. I'm not offering immortality to people. All I'm offering, in the immortal words of Esther Rantzen, is the chance to spend more of your life contented, useful, and interesting to know, which is what I think most of us want. And I can think of people of the age of 30 who fail to come up to that fairly low bar. And I would argue that even though they fail to do it, it is in fact what they want to be. And so with that, I know we have a tea break. I think I'm a couple of minutes over. After tea, please come back. Ask me the hard questions. Tell me if you agree with what I've said. Tell me if you don't. But above all, please tell me why, because that's the most important thing. And enjoy the tea. Thank you very much.